Hello everyone. In today's video, we are going to solve remainder theorem problem in 2020 A-level paper. You can see the problem in the screen. So, in the problem, they given function hx as x cube plus ax squared plus bx plus c, where a, b and c are real numbers. It is given that x squared minus is a factor of hx. Show that b equals minus 1. So, we have given that the x squared minus 1 is the factor. So we in this problem we have to apply factor theory. So I'm going to write. So I can write it as hx equals some function like gx into x squared minus 1, but there is no remainder, so I not going to write any remainder because this is a factor theorem. They given that x squared minus 1 is a factor, so this is the applying of factor theorem. So they given hx, I can substitute it x cube plus ax squared plus bx plus c equals gx times, I can factor x squared minus 1. This is the difference of two squares. So I can write it as x minus 1, x plus 1. So as in the earlier video, we have to remove this gx function. We don't know what is the gx function. So to remove this function, we have to substitute x values where this bracket are going to be 0. So when I am substitute x as 1, this bracket is 0, so all the term is going to be 0. Then again at x equals minus 1, whole term going to be 0. So I am going to substitute those two values. So first I am going to x equals 1, then 1 cube plus a 1 square plus b1 plus c equals, I am substitute g1 1 minus 1 plus 1 plus 1. Then I can get 1 plus a plus b plus c equals 0, which gives me a plus b plus c equals minus 1. Okay, I can then I am substitute x equals minus 1. Then I can obtain minus 1 cube plus a minus 1 square plus b minus 1 plus c equals g minus 1 minus 1 minus 1 minus 1 plus 1. So from this, this is my first equation. So then I can simplify this. Minus 1 cube means minus 1, minus 1 squared plus 1, then this is a minus b plus c. Here value is 0, so minus 1 plus 1 0, then total value is 0. So I can obtain equation from here as a minus b plus c equals plus 1. Okay. Then I can take, so I want to find the value of b. So I am using these two equations to find the value of b. First I modify this equation as, I am going to get a value as a plus c. So a plus c equals to 1 plus b. So I can substitute a plus c value to my first equation. By substituting my a plus c value, I can obtain value for the b. So a plus c is 1 plus b. So I'm going to substitute first equation. So there is another plus b equals minus 1. So this gives us 2b equals minus 2, which means b equals minus 1. So I easily solve the first part of the problem. Next we move to the second part of the problem. It is also given that the remainder when hx is divided by x squared minus 2x is 5x plus k, where k is a real number. Find the value of k and show that hx can be written in the form of x minus lambda squared into x minus mu. So in the next part there is a remainder. So when we can see the divisor is a quadratic function, so the remainder must be in the form of ax plus b. So when hx, I can write hx into px x squared minus 2x, remainder is 5x plus k. So I am going to substitute hx, x cube, ax squared. I don't know value for the a, but I know the value for the b. So b is a minus 1, and then b minus x plus c equals px. So I can take a in this term x squared minus 2x, I can see the x is a common to the both two terms, so I can take it out. Then I can write it as x into x minus 2 plus 5x plus k. Here also we have to remove the px function. To that I can substitute x equals 0 and x equals plus 2. So first I am going to substitute it x equals 0. At x equals 0, 0 cube a 0 cube minus 0 plus c equals b0 into 0, 0 minus 2, 5x means 5 into 0 plus k. So all the terms are 0, only c remains here. This total term is 0, then only k is here. So I get c equals k. Then I am going to substitute x equals 2. So at x equals 2, I can write it as 2 cube plus a 2 square minus 2 plus c equals b2, x value is 2, 2 minus 2 equals 10 plus 5 into, I can write it as 5 into 2, 5 into 2 plus k. Okay, then I can get 8 plus 4a minus 2 plus c. This whole term is going to be 0, then 10 plus k. I can simplify this. 8 minus 2 is plus 6. If I then 6, 10 minus 6 means 4. So I can write 4a plus c equals 4a plus c equals 10, 8 minus 2, 6, plus k. So from above equation I know that c equals k. So here I can see and k. Then this gives 4a equals 4, which means a equals 1. And in the above earlier part we get that a plus c equals I think 1 plus b or something. A plus c equals 1 plus b. So 1 plus b means minus 1. So then a plus c equals 0. Then I can write c as minus a, which means c equals also minus 1. So I know the a, b, c values and the value of k also. So c and k are equals, then the k value is also minus 1. And finally they want to show us this expression can write as x minus lambda squared, x minus mu in terms of these two. So here I am going to use the factor theorem and find the value. So they given that the x squared minus 1 is a factor of hx. So I can write hx as this. In the final part we have to show that we can write hx function as like this: x minus lambda squared, x minus lambda squared into x minus mu. So we have to find the lambda and mu values to show we can write this hx as this form. So here I am going to use the our factor. At the beginning of the problem we use factor theorem. So there I wrote that hx equals I think x squared minus 1 gx into x squared minus 1, right? So I gonna write it as gx into x squared minus 1. So both these two equations are equal, then I can write x minus lambda squared into x minus mu equals gx into x squared minus 1. Okay. And we know the exact hx function, right? So exact hx function is, by substituting abc values, it is x squared, so x cube plus x squared minus x minus 1. I write x squared minus 1 first. Then I can predict value of the predict expression for the gx, right? We focus on this step. So I am going to predict the expression for the gx. So we have to expand. So there must be a function, right? This function must be a linear function, because if there is a quadratic or higher value function, if we expand this we get x to the power higher power than 3. We can get x cube only if this function is a linear function and the coefficient of x cube is 1. So definitely I can think this must be x. So then only we can get x cube. And I can take the so we know that the linear function is a form of ax plus b. So there be a constant. So I can find the constant value by using my final value. So there is a minus 1. Then this minus 1 multiply by some number and again get the minus 1. So minus 1 multiply by plus 1 give us the positive minus 1 multiplied by plus 1 gives us minus 1 negative. If you expand this, you can get this. So I can name this function as gx. It is a very simple method, but you have to think a lot critically. You have to think critically to get the expression, right? So in next videos, we are going to use this method to get harder expressions, right? This is a very simple expression, so we can get it very easy. So I can write this hx as this. So then I can factorize x squared minus 1 as x plus 1, x minus 1 into x plus 1. So which gives me x plus 1 squared into x minus 1. So we have to show that we can write hx as this given form. So I can compare this to x minus lambda squared, x minus mu. So if we compare these two, I can say that minus lambda equals 1, which means lambda equals minus 1. Mu equals plus 1. So like this, I can show that we can write hx as they are given 4. Like this, we completely solve the remainder theorem problem in 2020 page. In next video, we are going to solve remainder theorem problem in 2019 page. See you in next video. Thank you.